We're now going to transition to an application domain of FL. We're going to hear from Sandra, Carrasco, Limeros, and Sylwia Majchrowska. Sorry for the names and pronunciations, but we're so delighted to have you here. They're both from Sweden AI, and they're going to talk about how the Swedish healthcare system ecosystem has been improving through the use of explorations with flower. So thank you so much for joining us. The floor is yours.
Thank you. Please let me know if you can see my screen.
Yes, we can see it.
Perfect. So, well, thank you so much. Thank you, Peter, for this amazing talk. And thank you to all the organizers for this amazing event. I'm Sandra Carrasco Limeros. I'm a PhD student, and now I'm also part of the SIIM-ISIC AI program at AI Sweden, where we work in different companies and different AI application areas. And today we want to share a little bit about one of our projects at Sahlgrenska University Hospital, created with Federated Learning.
So hello, I am Sylwia Majchrowska, and I'm working with Sandra. I am a PhD student in physics, and this work is about healthcare, so using flower in healthcare. And we conducted that project at Sahlgrenska University Hospital during our first rotation. So Sandra, please, next slide. Let's start with the main motivation for our research. According to the World Health Organization, skin cancer represents something like 1/3 of every diagnosed cancer. And as for each cancer type, early diagnosis here is key for a good outcome. And we believed that computers, machine learnings can show a great promise in such task, because neural networks can make prediction in few seconds. And in our case, we try to distinguish between melanoma and non-melanoma cases. But as we know, deep learning usually needs a lot of data, and usually internal hospital data is not enough. Next slide, Sandra. Oh, I believe we have some kind of issue. Okay, Sandra, are you with us?
Yes, I lost your sound for a moment. I don't know.
Now let's go to the limitations for data.
Okay, so I don't know if it was my problem or yours, but I lost you for a moment. So yes, data-driven machine learning has emerged as a promising approach for building these accurate and robust statistical models from medical data. And this medical data is collected in huge volumes, but the problem is that this data is not fully exploited by machine learning, primarily because it sits in data silos, and also because of all the privacy concerns that restrict the access to this data. And without access to the sufficient data, machine learning will be prevented from reaching its full potential, and ultimately from making the transition from research to clinical practice. And well, this is especially important for rare diseases, where collecting the data is much harder since the cases are more limited. But we should not only care about the amount of data, but also about the diversity of this data. We must ensure that we cover the real distribution as best as possible, and that our data includes underrepresented patient subgroups. So we need non-biased data in order to get robust and fair models. And lastly, in order to really advance AI research in the field, we need to share data with other researchers and other institutions in order to work together to address common problems, or to be able to reproduce results and build upon other works. And we believe that federated learning may provide a solution for all these problems. So in our specific use case, we apply federated learning in the field of dermatology. So we worked at Sahlgrenska University Hospital together with AI Sweden and Region Halland in a Swedish government-funded project called Decentralized AI in Healthcare, which aims to improve the Swedish healthcare ecosystem by leveraging the benefits of decentralized AI. So we tested different decentralized AI frameworks, and we decided to go with federated learning with Flower, given its flexibility and ease of use. So in our specific use case, we focus on melanoma detection, and we identified two main tasks. One is related with melanoma classification, where we perform different simulated experiments that we will explain later in order to explore the effect of data quantity, but also to explore the effect of data unbalance in each of the clients or hospitals, and also the instrumentation biases or or acquisition artifacts. And the other task would be the synthetic data generation of skin lesions based on local data from 3 different hospitals.
Okay, and in case of binary classification, so like Sandra mentioned, we want to distinguish between melanoma and non-melanoma cases. We worked with EfficientNet-B2 because this model is like quite a novel network and it performed well for this type of task during Kaggle competition, which were organized by ISIC, the team. And we used here like ISIC 2020, the latest version of the dataset. This is a very big dataset, but not ideal one. It's highly unbalanced because only around 2% of data is malignant melanoma cases. And also images have different resolution and quality. Our main finding inside the dataset, it was some kind of acquisition artifacts. You can spot some of them at the top of the slide. And some of them, like in case of black frames from the dermoscope, are strongly associated with the specific task, here with the melanoma, the black dermoscope. And also when we tried to generate synthetic data, we reproduced these artifacts. Some of them were enhanced, some of them totally disappeared. So main points to remember from that, we have highly unbalanced data set.
Okay, so the first experiment that we will explain is the testing of the size influence. So we simulated different scenarios with different number of clients and amounts of data per client, because in the end, the most interesting thing for the project is to know how federated learning would perform in a real scenario in Sweden. Because here in Sweden, the regions are highly unbalanced, are really different in sizes. So for you to get an idea, Stockholm region has around 23% of the total population, while Västra Götaland has around 16%, followed by Skåne. And then the next one is just 4% of the population, and the next one is 1%. So there is a huge difference in patients in all these hospitals. So we wanted to test how federated learning would perform in this scenario. So we kept the same class percentage representation in each client with around 20% of melanomas, and the client with the least amount of data improved from 74% accuracy in the global test set to 97.7%, which is impressive. And even the client representing Stockholm which already had a lot of data improved on 0.5 percentage points. So this experiment highlights the benefits of using federated learning in this kind of scenarios, where we can use the data of different regions without actually having to share the data with all the hindrances that entails. And next, we tested the class ratio unbalance. So we also made an experiment simulating 3 different hospitals, keeping the same size of around 1,000 images in each hospital, where the first client had 90% of melanomas, the second 31%, and the last one 1%. And here the biggest advantage was for the client with the least representation of melanomas, followed by the one with 90% of melanomas. So from the most unbalanced to the least unbalanced, as expected. And here the improvement was up to 20 percentage points. And lastly, we also wanted to explore the effect of the biases that Sylwia mentioned before. And here by biases, we refer to instrumentation biases or acquisition artifacts. So we performed an extensive study on these biases in our central model and found that some of these artifacts bias the model towards a specific class. And we wanted to explore if federated learning could help in this matter. So in this specific example, we simulated a hospital using a dermoscopy with different types of black frames, another hospital with rulers in all the images, and a third hospital with clean images, so with no artifacts. And here, size and class ratio was kept the same for our clients, approximately 1,000 images and 25% melanomas. And after performing federated learning, the test accuracy improves over 20 percentage points for the highly biased clients, which may indicate that federated learning can be used to mitigate the effect of these local biases and can help create more robust and fair models.
So we also performed the second task, which was just images generation. And here we applied Styleon 2 with ADA mechanism. This network is well known for the faces generation from the page, this person does not exist. But we wanted to generate moles and wanted them to look as real as possible. So we performed some kind of task to fool a doctor at the hospital, and we succeed with synthetic data. We, as first goal of our project with synthetic data generation, wanted to generate synthetic data and augment the classification task, because as I mentioned, we have a highly unbalanced data set. And we, on the next step, wanted to try with federated learning setup, because we believed that in that way, we can create more diverse synthetic data set. And here we tried with some conditional configuration with just given the network the image and the label. So network in the same time learn how to generate the images from some specific classes. And Sandra, please go to the next slide with the experiment. So here we come back to the setup with 3 clients. And these 3 clients have different amount of data per each. We shared the weights of both the generator and discriminator, and we found that flower is very flexible for that task. We can easily switch for another model and have our result. The main finding in that task was just observation of faster convergence, and also for the hospital with the less amount of data, the data set created was more realistic. And to wrap up our presentation, here we presented some main ideas. So we were working on tools which preferably will assist doctors during the diagnosis in the future. For that purpose, we utilized Flower framework to simulate collaboration between different medical institutions. And the main goal was to check possibility if we can simulate collaboration between different medical centers in Sweden. So that's why we have the experiments with different amount of data, different ratios, and we've mentioned biases. And the biggest advantage of federated learning use was observed for the institution with the smallest amount of data. And we also experimented with the data with different ratios of investigated classes, and that proved that balanced data sets leads to better results. And that's all from our side. I just at the end wanted to mention that it was our first project in federated learning topic, and this whole research was the part of A4AI program, which was created by AI Sweden. Thank you.
Thank you so much for the talk. It was, thanks for that very interesting talk.